See, for your class 12, this is the basic syllabus that I had discussed. So I think you must be aware of the syllabus. You have electromagnetism portion, which is a very huge portion of your class 12, not only from your CBSE board's perspective, but for your entrances as well, electromagnetism, which has so many lessons. Out of which we had started with electric charges and field. Then you have optics, you have modern physics, you have electronics lessons. So under electrostatics, no, it is that branch of physics that deals with when the charges are at rest. Statics means what? Something at rest. You must have done hydrostatics, hydrodynamics in your class 11. Similarly, here you have electrostatics, you have electrodynamics. Now in electrodynamics, we reach to this lesson, which is known as current electricity. So under your electrostatics, you have these two lessons, electric charges and field, and electric potential and capacitance. Now, yesterday we had started with electrostatics, electric charges and field. So a very basic property that you all should be aware of is what we discussed was electric charge. So electric charge is what? It is a very intrinsic property that gives rise to other phenomena. What all phenomena? Electric forces, electric field, such these phenomena. So SI unit you have to remember, because this is such SI unit which you have not done in class 11. This is a completely new topic. Nothing is related with your class 11th. It's just that the basics of 11th, which you have done, all the basic vectors, these will be used. Parallelogram law, triangle law, Cartesian form, polar form, all these will be added and that will be used. Apart from that, this whole is a new unit. So SI unit is Coulomb and CGS unit is electrostat unit or stat Coulomb. Two types of charges exist, positive and negative. Out of this, what you have to remember is one single electron or a single proton, this is holding some amount of charge. So Tarif, do you remember what is the value of electronic charge?
1.6 into 10 raised to minus C coulomb.
Minus 19 coulomb.
Yes. Minus 19 coulomb.
So one single electron, this is holding certain amount of charge. That value, all of you should remember, this value is 1.6 into 10 to the power minus 19 coulomb. For electron, we'll put a negative sign just to distinguish it from proton. And for protons, we'll put a plus sign. That is plus 1.6 into 10 to the power minus 19 coulomb. This much amount of charge is held by a single proton. And minus 1.6 into 10 to the power minus 19 coulomb is held by a single electron. So minimum quantity of electron can be one only. You cannot have half electron or 1/4 of electron. You have minimum value is 1 electron. And that minimum smallest 1 electron is also holding this much amount of charge, which is known as electronic charge. And please class, remember this value, this won't be mentioned to you in the exam. This you have to remember. And lots of lessons use this conversion. Just a single E would be written like this. Just a single letter E will be written, from where you have to identify, you have to perform the whole conversion by yourself. All right, now one more thing we discussed was how we say a body is neutral, positive or negative. These are all just basics. When the number of electrons and number of protons are equal, we say a body is neutral. Means net positive charge, net negative charge, both have cancelled each other and we have a conclusion that the body is neutral. But we had seen two forces. One force was nuclear force. Nuclear force was holding the proton tightly into the nucleus. It wasn't letting the proton escape. It was such a strong force. Details we'll discuss in nuclei when we'll be dealing in modern physics. Second force was electrostatic force. These are weaker forces in comparison to the nuclear forces when you compare it with it. So these small weak electrons are revolving around the nucleus. So of course, since nuclear forces are strong, they do not allow the protons to move. But since electrostatic forces are weaker in comparison, so they allow the electrons to move. So actually it's the transfer of electrons that takes place, which leads to the formation of a positive or negative body. If from a body, if electrons are moving out, so that body which has now deficiency of electrons are not present, electrons have moved, that body becomes positive, and the body that gains these electrons, it becomes negative. This is what is the mechanics behind transfer of electrons. Now for transfer, we also use the term charging. Charging is a process by which electrons are moved. So this is also what is the same thing which we were discussing. See, one more thing. When we say a body is negatively charged, so it means electrons have come into the body. That's why the body has become negatively charged, right? But see, one electron has also 9.1 into 10 to the power minus 31 kg of mass. So if a single electron is coming into this body, 2 electrons are coming, 3 electrons are coming, they are also increasing the body's weight, because whatever weight is held by electrons are not massless entities. They hold such a weight, small, very small amount of weight, but when numerous electrons are transferred, the mass also increases. So for a negatively charged body, 2 points you have to remember: it gains electrons and the mass also increases. Just the opposite occurs for positively charged body. It loses electron and the body loses the associated mass with the electron as well. So it becomes light in weight, as in the mass decreases. So this is the basic conclusion about positive, negative, and a neutral body. Regarding the transfer of electron, how the transfer of electron occurs, there are basic 3 processes. Only I think one we could discuss yesterday, charging by friction. Conduction and induction we have to do it today. Okay, let me revise charging by friction so that we can at least practice some questions on it. See, when 2 bodies are rubbed against each other, what happens? The irregularities between the body leads to the formation of frictional force. So whatever is the work done against this frictional force, you must have done all of this in your work energy in power in class 11. So whatever is the work done against the frictional force, always remember frictional force is a dissipative force. So it leads to the formation of heat energy. All the frictional force gets wasted and dissipated in the form of heat. Now whatever heat is generated between 2 bodies, that allows the transfer of electrons to occur. So one mechanism is charging by friction, means transfer of electrons from one body to another through the help of friction. And which quantity governs it is basically the work done. All right. Now, how do questions come? One question we will practice based on the example which we did yesterday. The example which we did yesterday was this: a body A is there having 4 positive charges, 4 negative electrons. Fine. B body is there, that is also having 5 electrons and 5 protons. So if you see individually, net charges are 0. 4 electron, 4 proton, making the body neutral A. 5 electron, 5 proton, making the body B neutral. So both the bodies are neutral currently, right? Now see, what if the condition is given to, electrons are strongly bonded in B as compared to A? Means electrons, both the forces are weaker forces. But if electrons are very tightly held in B and electrons are, as in comparison, they are not held as tightly as in A as in B, right? So which will allow the electrons to move? Definitely A, because there the force is a little weaker, right? In B the force is stronger. So if such conditions are given to, where electrons are tightly held, this makes the question distinguishing from your other concepts of charging by conduction and charging by induction. So wherever transfer of electrons will occur, it's easier to remove electrons from body A and the body B will gain electrons. So from neutral, A will become positive. From neutral, B will become negative. Now, how do questions come from this part? Is just note down this question. First note it down, try it also yourself. I'll discuss it. First note it down. Now look, let me discuss it with you. See, it says that if an object made of substance A is rubbed with an object made of substance B, then A becomes positively charged and B becomes negatively charged. So if this is the case, it means A body is there, this is positive, and B body is there, which is negative. If questions, if any numerical or if any type of question has to come from this portion, no charging by friction, apart from the theoretical definitions, these types of question can only come in your board examination. So A is positive, B is negative. It means what would have happened? You have to analyze this to solve the further question, because it's saying if, however, an object made of substance C, a random third object substance C is added, then A becomes negatively charged. What will happen if an object made of substance B is rubbed against an object made of substance C? First, understand the question. A is positively charged, B is negatively charged. It means initially they must have been neutral. Some charges must have flown from A to B or B to A. Tell me this. If A is positive, then A would have loosened its electron or it had gained some electron?
Again.
Gained.
Yes, sir.
See, if it gains, it will become negative. If a body is positive, it means it has loosened electrons. Loss of electrons lead to the formation of positive body, no? So here also what will happen? If A is positive, B is negative. It means from A, electrons have moved into B. That's why this is negative now and this is positive. So if A is allowing electrons to move, for itself becoming positive, if it is allowing the electrons to move, it means electrons are weakly bonded, right? Then only the electrons are able to escape from A. Otherwise, if it would be having a very strong bond, it won't be allowing the electrons to move. It wouldn't have become positive. Since it is positive, it means that the electrons are in comparison to B are held a little weaker. That's why it is allowing the electrons to escape. So what conclusion can we draw about A? Electrons are weakly bonded than B. This is what is our conclusion. Now see, what about A and what about C? What is the question saying? It is saying that if an object made of substance C, means C and A are rubbed, A becomes negative, so by default C becomes positive. It means this is saying A is negative, and if A is negative, then obviously C is positive. So it means in C, electrons are weaker, right? Because C is positive this time. It has allowed the electrons to escape from itself and led to the formation of negatively charged A body. Yes, A gained electrons from B. C lost electrons. So C became positive, A became negative. Now it means electrons are weakly held in C. That's why it allowed the electrons to escape. So now what conclusion you can draw about C? Electrons are weakly bonded than A. So C, what we have to find out? We have to find out if B and C are rubbed, which will be positive, which will be negative. C, affinity of A is less than that of B, right? From this first conclusion, and affinity of C is less than that of A from this conclusion. So it's like, what is the order? C is lesser than A, which itself is lesser than B, the affinity or the strength. So it means B, the strength or the force of attraction is stronger in B and weaker in C. Electrons are held tightly in B and they are held loosely in C. So which will allow the electrons to escape, C or B? Look at this class. In B, electrons are tightly held. In C, electrons are loosely held. So from where electrons will move? Will B allow electrons to move or C will allow?
C.
C, yes, Rabia Numam. C will allow, no. So it means C is allowing the electrons to move out. And if the electrons are getting escaped, it means the body is positive because it is having weaker forces. This is the weakest of all. This is the strongest of all. So this will become positive since it will lose electrons, and this will become negative since it will gain electrons. This is how, since we were discussing it into so detail and I was repeating on things, that's why it took a long time for us to solve just a single question. Otherwise, these types of questions, or questions from charging by friction, charging by conduction, they do not take time in your board exams. It will just take you 2 minutes to write down the solution with full detail. The answer will be within seconds in your mind, just to note it down properly, because in board examination, there's a certain proper way of writing that we'll be discussing throughout the tests, through the test sheets when we'll be having it. Fine. So this is clear how to solve these types of questions. Clear or not?
Yes.
Okay. Note it down. If anyone wants to note down the question also, let me know if you haven't. Otherwise, note down the solution, then we'll start with charging by conduction.
Done, ma'am.
Completed. So if anyone is writing, please stop me. Otherwise, I'm moving further. Okay, charging by conduction. See, charging by conduction is also not difficult. Easiest is charging by friction, just rubbing of two bodies. See, in charging by conduction, the basic phenomena, the basic concept remains the same. That transfer of electron is occurring from one body to another because of heat and all. In conduction, you just place the two bodies in contact. In friction, what were we doing? We were rubbing two objects, and that heat that was developing, that was becoming a medium for electrons to transfer, to get transferred. Here in charging by conduction, you are just taking two bodies, you are just placing them in contact with each other. Just place the two bodies like this. They are just in contact with each other. This is body A, this is body B. Now, how does the transfer of electrons occur? It's just because of the contact direct from one medium to another medium. What was the medium in the previous case? Heat. Heat was acting as a medium. No, here direct contact, because the two bodies' peripheries are coming in contact. From one body to another body, electrons are directly getting transferred. So here you do not have to do any work. Work isn't done. Simply the contact force allows the electrons to move. So how would you find out? For example, if I, let's say, give you two bodies, let's say this is A. The charge on this first body is, let's say, 4 electronic charge. Electronic charge, I hope I'm again repeating. I think Rabia has joined late. Electronic charge is basically the amount of charge that is held by a single electron or a single proton also, you can say. That is known as electronic charge, whose value, please remember, it's very important and it's very basic value. 1.6 into 10 to the power minus 19. So if you both want, you can take the link also of yesterday's class so that you can brush up with if any portion you want to go through and to write up the notes also. So this is 4e. 4e means 4 times the electronic charge. And let's say second body is having 0, right? This is having 0 amount of charge. Now, see, if I say, I want to find out after conduction, each body is receiving what amount of charge. So see, total amount, if the bodies are unidentical, let's say one is a larger sphere, one is a very small sphere, and they are kept in contact with each other, then redistribution can occur in any manner. Some after redistribution of charges, it can still be 0, it can be 4e, it can be 3e, it can be 1e, anything. One case which is very important for your board examination, because that case is only given, is when the bodies are identical. That case is given. If the bodies are identical bodies mean what? If two spheres are there, their radii are equal. If two cubes are there, their lengths are equal, right? Like this, bodies are identical, same. If your spheres are identical, then what will happen? Charge distribution will also be equal. And you get questions from this part only, where identical bodies are given. You do not get questions from unidentical bodies. You have questions from identical bodies only, because there the charge distribution is equal. Fine. So now see, how will it happen? Let's say these two bodies, let's say this is A, this is B, they are identical. How the charge distribution will occur? What is the total charge right now? Total charge is, the total charge is 4e plus 0, that is 4e, right? So 4e is the total charge. So distribute it into 2. Give one amount of segment to A body, second amount of segment to B body. So simply divided by 2, that will become 2e. It means after placing them in contact with each other, A will be having 2e, B will also be having 2e. Now no more transfer of charge occurs. And there is some more physics concept in this that we'll see in electric potential and capacitance. That time that will be discussed, but till now and for this lesson, you have to remember just this part. All right. Some other example also we can take. Let me give you an example. Let's say I have body, this is one body, this is another body, this is A body, this is B body. Let's say Q charge on A is 4e and charge on B is minus 80. So how much amount of charge each will receive? So again, for this, add total charges. 4e minus 80 means plus 4e minus 80 divided by 2 for equal distribution. So that becomes minus 4e by 2, that is minus 2e. Means this will also receive minus 2e, this will actually become minus. Fine. This is how the transfer of electrons occur in conduction. Note down this portion, whichever doubts you have, get it clarified. After that, one question I'll give you from this topic, then you'll discuss. And questions from this are like this only. A is rubbed against B, B is rubbed against C. Now what amount of charges are left? Like this only.
Done, ma'am.
See, Tarif, always it's not equal. If the bodies are identical, then only charges will be equally divided. It's don't think if the body, don't generalize the statement. Though in your exam, only identical part is usually asked, but just keep it in the back of your mind that if even if it can happen that the charge distribution can be unequal. So it is in that case when the bodies are unidentical. Like if a sphere of radius 2 meter and another sphere of radius 4 meter is placed, right? So in such case, charge transfers can be unequal. If bodies are identical, charge will get equally divided.
Done, ma'am.
Okay, for all of you have written, I'll show you the question then. Okay, you note it down. I'll give you 2 more minutes. For those who have completed the writing part, note down this question in the chat box. Let me know what is the answer for each of the charges A, B, C. Using just the above concept only, because all are identical. At least try this. Just the method is add all the charges divided by 2. Add all the charges divided by 2. Use it. Let me know the answer. A and B. Okay, Tarif has answered. Okay, I think both of you, Tarif and Rabi, I think both of you are getting the same answer. Plus E, no, for A and B. See, I'll tell you. Let me discuss it. Wherever you are getting issues, let me know, whichever part isn't clear. This is A body. This is saying, question is, two identical spheres A and B have charges plus 4E minus 2E, right? A and B. A third identical and uncharged sphere, means C is having no charge, 0, is first placed in contact with A, right? So it means A is there already having plus 4E charge, and C is having no charge, 0 charge. All right, C is having no charge, it is having 0 charge. C is uncharged, it is kept with, means conduction occurs, kept in contact wherever this term is used, directly related with conduction, because directly it won't ever give you the term conduction. You just link it with conduction. Now, 4E and 0, now at least you can tell me if A and C, they are kept in contact, each will receive how much charge? 4E plus 0 divided by 2, that is 2E. And same thing here also, 4E plus 0 divided by 2, that is 2E. Fine. Now A is having 2E. Now C is having 2E. First, it is first placed in contact with A. So now this is the state of C. C is no more 0. Now C is 2E. Secondly, it says that then with B, C is made in contact. So C is it. Now C is made in contact with B. C is having 2E charge. But what was the charge that B was holding? Minus 2. Minus 2. So C, total charge minus 2E plus 2E minus 2E by 2. That will cancel, will become 0. Same way, minus 2E plus 2E divided by 2, that will cancel and 0. So what is the conclusion that you can write about these charges? Conclusion is A has the charge now plus 2E, B is having charge 0, C is also having charge 0. This is how you take. Go according to the manner in which the question is asked. Whatever is the manner, no? First with this, second with that, then only. Because after first contact, the charge becomes different. Note the solution. Text me done in the chat column. All of you, because everyone has a different speed. So in the chat column, I think it's better. Then I'll start with the last one, charging by induction. So methods of charging will be done. It can come in your theoretical questions, 3-marker questions that are there in section C, there it can come. To write about all of these. Charging by friction, conduction, induction. I'll start with induction. Done, class?
Yes.
Let's discuss charging by induction. See, charging by induction, or this is used to isolate charges, basically without making the bodies in contact or without executing frictional force, how to separate the charges, or how to make a body neutral, or how to make a body positive or negative, but without direct contact. We're just using the properties of charges. So in detail, we haven't discussed the properties of charges, but this basic thing you all know, that positive and negative charges exist, and if two positive charges are there, then they'll repel each other. If two negative charges are there, they'll also repel each other. But if one positive, one negative is there, they will always attract each other, right? Unlike charges, they attract, and like charges repel each other. This is a very basic concept that you all have been doing this. And one more thing also, class, whatever syllabus was there in your class 10th, this 12th class resembles that only. So all the basics of electromagnetism you already are aware of. That's what is being used here in just an elaborate manner and in detail. Now in charging by conduction, I have taken a neutral body here. This is a neutral body, right? Whatever amount of positive charges the first row is holding is exactly amount of negative charge it is holding. And same way, positive, negative. But one thing you should remember about the positive charges, that these positive charges are static charges. They do not move. I'll write it down. Positive charges are static. It means one more thing, class. When I'm writing on the screen, then just have patience, then do not write. When I'll give you sufficient ample time for all of you to note it down. All right, so that otherwise you won't miss anything when I'm speaking. So positive charges are static. They are at rest. They do not move. But when we talk about these negative charges are mobile. Negative charges are mobile. They move. So right now, positive and negative charges, they are canceling each other. The body is neutral. Now what I'll do, I'll just bring a rod. Let's say a glass rod I have brought. This is a glass rod. And let me make this glass rod as positively charged. I have brought a positively charged glass rod. We know how to make a glass rod positive. Okay, some of you were not there, no, yesterday. This is a basic concept that is given in your NCERT. In your NCERT textbook in a very hidden manner about glass rod and silk. It's like if a glass rod is there. Let's say this is a glass rod. This is rubbed with a silk cloth. Let's say if I rub it with a silk cloth. So what happens? Glass rod loses electron and it becomes positive, while the silk cloth gains electron and it becomes negative. Same thing happens with wool and plastic. When wool and plastic, they are rubbed against each other. Plastic acquires the charges, while the wool cloth, that becomes positive. So there are so many things, but you don't have to remember for everything. Just remember these two because they are specifically mentioned. So questions modification, if it becomes very difficult, can be from this part only, right? From glass rod or silk rod. All right, so glass rod, silk, and wool and plastic, at least these two combinations you should remember. Rest of the combinations you don't need to do in detail or remember it because obviously they are not included. They are not a part of your syllabus. And it's very difficult to remember which is gaining positive charges, which is losing electrons. Now see, suppose I have brought a glass rod, you know how to make it positive using silk cloth. Now, if I take this glass rod near this neutral body, what will it do? This glass rod is there. This is having all the positive charges, and I have brought this a little in the vicinity of this neutral body. All the negative charges slowly, they'll get attracted towards one end, right? If I say this is the body, This is the glass rod. I have not placed in direct contact, but somehow near the vicinity of it I have kept. So what will happen? All the charges, negative charges that were distributed equally, they are coming towards the edge. They are getting attracted by the rod. So all the positive charges and negative charges, which were initially neutralizing in pair and making a combination, now they are getting slowly and slowly and slowly separated. If you bring up a negatively charged rod, all the positive charges will come. So ultimately at the last, what will happen? You can clearly see a demarcation between positive and negative charges, right? One more thing, class, charging by induction, this concept, charging by induction. This is also known as temporary electrification. Why is it temporary electrification? See, till the time this glass rod is kept, because of the attractive forces of the positively charged glass rod, the negative charges are getting accumulated like this till the time I'm holding the glass rod, right? Till the time I'm holding this glass rod over here. Only till that time, though the negative charges are here, as soon as I put the rod back here, I have shifted the rod. What will happen? Here were the negative charges, all the positive charges were here like this. They'll slowly neutralize each other. One positive will cancel one negative, one positive, one negative, and again it will become neutral. So temporary electrification means till the time the glass rod is there, the object is having the charges as separated. When the glass rod is removed, it becomes again neutralized, back to neutralization. So these charges which are getting separated, we call these charges as induced charges. You have a full detail about electromagnetic induction also. It's, I think, sixth lesson, yes, sixth chapter of your NCERT part 1. There you will see this in detail. A very short and easy lesson it is. But basics is this only, which will come from this part is charging by induction. And what is the charges that are held by the glass rod cord? These are inducing charges. These are inducing charges. Inducing charges make the other charges as induced. They induce, right? So the phenomena of the separation of the neutral charges, or you can say the phenomena of the charges becoming induced through the aid of inducing charge. This phenomena is known as induction. All right. Temporary electrification can also be used for as a synonym for charging by induction, or directly you can use the term charging by induction. This is what it is. Now, questions are there in your NCERT textbook, back exercises and in-text questions also from this part, but it's just that you have to answer this in the form of diagrams only. I'll tell you. Note down this part. One question I'll tell you how to write the answers in this. I'll scroll it down after some time and keep on updating me in the chat box. You can always keep on texting me. Whatever doubts you have, you can unmute yourself also ask. You can text me in the chat column also. Fine. Yes, the positive charges remain at rest, negative charges move on. C class, one phenomena that is used in the questions of induction is earthing. So earthing, you have the basic details of earthing when we do potential, but some of the things remember for at least the solving questions part of charging by induction. So see, whenever a body is connected to earth, transfer of electrons occur and its potential becomes zero. So instead of potential, no, right now just understand that net charge is zero. For example, if I have a body, this is the body, I have earthed it. Class, remember, this is the symbol for earthing. Wherever, no, in your any of the circuits, further also you will be having DC circuits, you'll be having AC circuits in your syllabus. Wherever you see the symbol, no, this means earthing. And potential here becomes zero. Means it allows all the charges to escape. Basically, what happens, whatever amount of charge is held, let's say positive charge is there. So from the body, From the earth, actually, the negative charges will come and neutralize. Now, whether the negative charges will flow from the body to the earth or the negative charges from the earth will come, that depends upon the charge that the body is holding. Just remember one thing, if the body is negative body, then electrons flow from body to the earth. If it's a positive body, then electrons flow from earth to the body. Just this small concept will be used in the upcoming question. Note down this as a separate, make it as a note, mark it as a note, write earthing, and then I'll tell you, we'll discuss at least one question from this. This much, Tarif, this part?
Yes, ma'am.
Done?
Yes, miss.
Yes.
Okay, see, question is, this is given, this is isolated sphere, this is neutral right now, but you have to make it as positively charged sphere by using the method of induction, definitely, because other methods are not possible even to make this as positively charged sphere. So by induction, you have to make this sphere as positively charged. So this is just an insulating stand. Why insulating stand? So that electrons do not move down the earth, right? Electrons do not, earthing does not take place. And sphere is kept on the insulating stand. Now what will I do in order to make it as I have to make this as positive. So this is the sphere. This is the insulating stand. Initially, all the positive and negative charges are balancing each other. It's a neutral object. I'll bring a negatively charged rod. Now what will happen? Positive charges cannot move. They are static. They do not move. So what will it do? It will repel all the negative charges. Whatever negative charges that were held by this, it will repel it. So what will happen? All the negative charges will get repelled. So what will be left at one end? Positive charges. But there is one problem with this. As I'll remove the rod, again neutralization will occur, right? Because this phenomena is temporary electrification until and unless the forces are holding the positive charges tightly here, then only they are staying. As soon as the inducing charge is removed, induced charge also mix up, right? So now we'll apply the concept of what we have studied, that is known as earthing. Right now we had seen, no? Now what we'll do, this is the sphere, this is the rod that is having negative charges. These are positive charges. I'll earth it. Now, once earthing is done, that is potential is zero. Here, the charge is becoming, instead of potential, no, you can remember the term charge has become zero. That will be a little easier for you to understand till now. So what will happen? All the negative charges, they'll move, they'll get neutralized, right? So negative charges have gone. Now, what is the scenario? What is the case? Now, the sphere is there. Only positive charges are held at one end because of the rod, at only one end. Now, even if you remove this rod, what will happen? The positive charges that were held at one edge, they'll just redistribute. So successfully, you have converted a neutralized body into a positively charged. This is now positively charged, isolated sphere. Fine, note it down. So any case can be given to you like this to convert it. Right? This actually, the starting portion is easy. Now, when we'll start with properties of charges, there is one property, quantization of charge. That is the most important. From there, numericals begin. Till now, you haven't seen any numerical as such. No, these are just theoretical conceptual questions. So from this starting portion, conceptual questions can come. Questions have come, and since questions are present in your textbooks, NCERT especially, they can come. Note it down. Text me done in the chat column when you have completed. Any doubts if you have, you can ask. I think it's already time, because properties of charges is a little big portion, not a very big portion, but out of it, one of the properties, as I was mentioning about the quantization of charges, that is very important. So now next Saturday, I'll start with that, revise this part, methods of charging, basics of electric charge. Those who haven't attended the yesterday's lecture, do let me know. If you want link of yesterday's class, you can use. Van de Graaff generator uses induction, but more or less it has work of potential. So again, same thing, that earthing part that arises, no, where potential is used. So that part is more used in the Van de Graaff generator. Fine. So any doubts if you have, you can ask. Get connected on WhatsApp throughout. Whichever doubts you have, you can let me know, please. And one more thing. You all must be having in your apps these questions, right? So at least for today, question 1 and question 2, at least you can try it by yourself. Because this, since quantization is not done, so I'll not even insist that, I'll not make it compulsory for all of you. But in your app, you can at least attempt question 1 and 2. If not, if you're not able to do, don't worry, we'll do this topic in the next class. Just 1 and 2 if you're able to. All right, class. So yes, you can leave if you have completed. All right.